Got it. Recording in progress. So in terms of the systems that we do, most of what we do is going to be advanced treatment systems. So in my definition of that, it's a lot of pump and treat, right? Versus maybe gravity or passive fed systems. So we're doing things like pH adjustment, chemical treatment, clarification systems, filtration, ion exchange and membrane systems, disinfection, etc. And we'll talk about kind of some of these in the context of other case studies and lessons learned later on. But in general, these are some of the categories of things that we're integrating in industrial stormwater and industrial wastewater projects and things like that. Okay, great. In terms of California experience, right, we've worked, I think our first project was in 2004 at the Port of San Francisco, our very first little system. And then, have expanded from there over the years, from as far north as Chico, as far south as Chula Vista, and, kind of all sorts in between here. So just an example of some of our sites. And if you live or work in any of these spots and want info on something specific, just let me know. So. Also, since this theme is back to the future, I thought I should highlight the fact that, we've done some previous presentations here. Last year we did TMDL and PFAS presentations. So if you're interested in either of those issues, total maximum daily loads on the general permit, or PFAS, PFAS, PFOA, et cetera issues, either click these links or hit those search terms into YouTube and you can find those videos. Awesome. Okay. All right. So here we are, top 5 pitfalls. And these are, objective as said in textbooks. No, these are my opinions, right? In my lessons learned over the years and things that when I think about a project starting out, what are the things I try and keep in mind, because, they're pitfalls for myself too, right? It's easy to kind of just get into a project and let that project develop a life of its own and carry you along, right? And so, and I can tend to have an optimism bias personally. So I try and always, harken back to these things, right? Hey, these are things that could go sideways, right? And try and get ahead of them, right? Think about them in advance. And so I'll share a few kind of stories from each of these areas and kind of how you navigated through them and go from there. So my pitfall number 1 is not being on the same page, with everyone on your project, or other titles I thought of this, misaligned expectations, right? Another way to kind of phrase it. Number 2, making assumptions about data. When we look at our water quality data or any other sort of data that we're using to make critical decisions about our project and what we think will happen, we can make some bad assumptions there. So what are some of those we've looked at? Time, not leaving yourself enough time. A lot of these projects, in my experience, are plagued with time issues. There's a lawsuit, there's a water board order, there's a city order, there's a third party, et cetera, et cetera, et cetera, right? And there can be a number of factors that get shoved into the schedule that all of a sudden start to make the project look like it's going to take a while, and it does. So talk about some of those schedule challenges. Number 4, just the general catch-all of assuming all will go smoothly. So this is my area where I'll kind of highlight some what are the other things that can kind of get wrapped into these projects that can slow them down, trip them up, present challenges, right, for you and your teams. And the last one that I've got here is pitfall 5, not appointing a champion, right? So when you get this system or solution or whatever you end up doing for your site for stormwater controls, right? Kind of just who takes ownership of that, these can be, oftentimes, whether it's something small or something, small and inexpensive or large and expensive, either way, like someone's got to take ownership of it, right? And kind of like, whose responsibility is this? Who's managing it? what are the, the incentives and, stakes for all the people involved, kind of understanding that. And I've really found that when you've got kind of a single person that's really kind of driving and owning it, it really, really leads to a lot of success. So, okay. All right. So pitfall number one, not being on the same page. So what I kind of try to do here, I mean, there are so many stakeholders in the stormwater, industrial stormwater world, construct, any of these projects, right? So I want to kind of just tick off some of the ones that I see, some of their goals, right, on these types of projects, and how do you, I assume maybe some of the folks on this call are environmental managers or maybe they're, consultants, et cetera. But often, someone at the center of kind of trying to manage these different perspectives, right? And to get people on the same page. And then I'll kind of tick off, each of my slides here, I have a kind of a set of stories, 3 to 4 that I'll highlight kind of as examples, right, of this pitfall. So, in our little diagram here of our stakeholder web, so council, the lawyers that may be on your team as part of your stormwater project, maybe you don't have lawyers on your team, if it's maybe a lower stakes situation, and great, right? Because lawyers are expensive. But, in the case that you do, right, they're trying to help you, guide you towards some sort of, legal resolution, right? A settlement, right? Or satisfying of a consent decree, or some other sort of order, trying to keep you and your business safe in that way, right? Their motivation is kind of separate from, these other items. You've got your stormwater consultant, or maybe it's an engineer or other sort of individual right there that you pay to help you with permit compliance. So things like submitting your reports, collecting your samples, filing your paperwork. And, I think from their standpoint, they want to make sure that you are in compliance, right? They don't want to kind of look back and have someone come to them and say, oh, hey, why wasn't our tier 2 report filed on time? Or why were our samples not collected within the, the time period of the storm event we needed, or, et cetera, right? So, their goal is to kind of make sure that you are as in compliance as you can be. You have probably some, whether a CFO or maybe just an owner, or however kind of your finances are managed. If you're looking at one of these projects where you're saying, hey, we have to spend some money, right, to put in, whether it's a filter sock or a filtration system, what's that going to cost, right? And kind of managing that capital budget, and certainly probably trying to manage it to the lowest number possible, right? That can still balance with those other items. Your operations team, right? What's the impact to your business? Just looking here at this picture on the right, this equipment can take up space. Presumably, a lot of places in California, that space is valuable. They've got to either, a lot of people don't just have that space sitting around, right? They've got to either make it happen, take it away from other business operations, maybe get land next to that, et cetera, right? There can be other things. Also maybe where you want to be treating or dealing with your water on your site is not the best place for it to be operationally, right? Maybe where you have different water flows or catch basins or ponds or things like that is maybe you need to move that around, right? As you kind of think about, hey, how does my whole business and operation kind of interface with this, treatment aspect that I have going on my site? And certainly, maybe that operations team isn't thinking about it, right now, prior to anything showing up at their facility, but certainly they will be thinking about it once those shipments start arriving, right? And you start getting, materials or equipment and other things being stored on the site, and seeing how that impacts what's going on day to day. You've got your product vendors. So, someone like myself or any other, a vac truck company cleaning out your catch basins, a media company, replacing media, et cetera, et cetera. And I would say they have kind of maybe a more narrow view of just kind of their own unit process. Like, how well is this catch basin working? How good is that pond performing? How clean are the pipes over there in that system, right? So kind of keep that in mind too, right? That, you know, you may have kind of a whole network of different product or vendor suppliers, but, you know, their visibility to your total issues, right? Around, you know, full compliance on your site with all the different things you're trying to do, right? They may not understand, you know, how what they are doing at their step, you know, is impacted upstream, downstream of other things you're doing. You've got the water board, right, which can have all sorts of perspectives, opinions, letters, etc., on what you are doing on your site and how that may impact your operations. I'll speak to some examples on that there. You've got like a site general manager, right, who's looking at the P&L for that facility. Like, hey, is it make sense to continue running this operation, right? I mean, I've certainly had people that have had to shut down their businesses, right, which is very unfortunate, you know, because the cost of compliance, and maybe it wasn't just water, right? Maybe it was many things, you know, that a site was being pinged for. But they're going to be concerned with, you know, maybe less the operating costs, right, where you know, a CFO can look at and capitalize that expenditure, but they're going to look at, you know, what's the operating cost, right? Do I need an extra body here to manage you know, these different assets I have on site? What's this going to cost me, you know, every month, every year? How predictable is that cost, et cetera, right? And then, you know, also back on the legal side here, maybe you've got a third-party litigant here who, you know, may have various motives, from, you know, the more altruistic water quality improvement motives to maybe more fee-based motives, et cetera, right? And how they can often drive a lot of the activity. You know, if you're being, you know, a lawsuit is being brought against you and they're saying, hey, we want you to do X, and then this lawsuit will go away. Well, then you'd say, okay, well, I see a lot of people that come in and they say, okay, well, I'll do X because I want the lawsuit to go away. But doing X doesn't necessarily mean, you know, you're in permit compliance, or that it was a good business decision, or that it's going to meet your water quality goals or anything else, right? And so that can be, again, a totally independent stakeholder of all these other things. You know, sometimes that's the right answer, is to just kind of take, you know, let them take the lead and follow their lead and kind of look to do what they're saying. But other times, you know, you may want to push back on that. So I think you see a lot of stakeholders in this web. Just give you some examples of things I've seen here on some projects. One down in Carlsbad, you know, in terms of trying to just get a project under contract. You know, this is one where, you know, they were in a precarious legal situation, and so because of that, you know, a lot of lawyers involved, and I think they wanted to be very cross their T's and dot their I's with everything they did, right? And so what that kind of turned into was some very complex and drawn out contracting. You know, they got to version 18 of the contract that they were trying to execute with everyone, and they still couldn't do it. And they just said, okay, well, we're just going to start over. We're just going to, you know, wipe that one clean and try again with a new version. You know, I mean, that was after like 6 months of. I mean, you think about all the time that goes into something like that, right? So, you know, that's you know, one example on the legal side, you know, just trying to manage that. Example on the budget side here of a motivation, the project in San Jose we had that, you know, the engineer team and everyone that was kind of involved in scoping the project, you know, took a lot longer to get through the procurement and the selection. And by the time they got around to, you know, awarding the project, you know, the CFO was like, hey, you lose these funds at the end of the year, you know, and you're not getting them back next year. You know, or for them to get them back, right, was going to be a big challenge. And so, you know, I see that happen a lot, right, where kind of the timing of projects, you know, can take a while, and then when they're budgeted versus when they're actually ready to pay for them, what they ended up doing on this is we ended up, building the system for them and being able to deliver most of it within the time frame they wanted. But they just kind of put all of the funds into, the first year. And then the equipment just sat there for a year and a half, prior to it being installed. So they kind of, were like, well, we have the funds this year, so let's buy it and get it done, even though we have to do all this construction work and permitting work that isn't going to happen for 18 months. We have budget now to buy this equipment. So, it's an interesting choice again, but that I've seen it happen multiple times. Waterboard example here. As a stakeholder kind of weighing in, I mentioned before that a lot of the projects we do have treatability studies, right? So clients coming to us and sending us water samples, us kind of validating out a treatment approach and saying, hey, here's what looks to work well on your site, right? We're going to adjust pH, we're going to add this chemical or not, we're going to filter at this rate or not, settle, et cetera, right? Well, the water board came back on a site in Oakland that we had this whole plan. We'd already installed everything, and they said, well, actually, you only did that one time. One data point doesn't seem like a very robust data set. We would like you to do that 10 times again. And we said, like, repeat the exact same thing we did just 10 times in a row. And said, yes, exactly. I was like, okay. So we did that. It was interesting. And I mean, the results were it was pretty much, a deja vu of the same thing 10 times. Now, where that maybe would have been more valuable if you said, hey, I want you to collect water from 10 different storms, over the course of a year. Okay, that could be a more interesting data set. But, I mean, again, I don't want to question or say it's bad, but, it was a peculiar request, and not something I get often, but something that we've seen pop up here, right? And I guess the general theme there is kind of the water board has a stake and an interest in kind of saying, hey, what's the extent that these solutions have been validated, right? That this engineered approach, the consultants, engineers, clients working on the project have kind of worked through all of the potential issues. So. And last one here, as a kind of a third party, litigant, there was a consent decree project in the Sacramento area I was a part of, and I've seen this happen multiple times. It can be difficult where, as part of their settlement, they said, hey, in addition to the things on the industrial general permit, we're also concerned about these other pollutants, right? And so we want you to sample for those too. And sometimes the list that they come up with is fine and not things that people have issues with, and other times it's things that are more problematic, right? In terms of the risk to the facility on, well, what does it mean if they don't meet these extras, right, that this third party wanted, even if they're not on the general permit or somewhere else, but then they start sampling for them and they develop a history around this data. I guess I've really seen these more as kind of like the third parties trying to kind of get some additional monitoring data out of these suits to say like, hey, we're curious about this certain parameter. We think it may be an impact on, water quality in this stream or waterway. And so we want you, company X, who we think is maybe a discharger of this, to kind of sample for it. Maybe we can't, bring a heavy hammer against you if you, are, missing some target that we have in mind. But, it's still, nobody likes to be opened up to kind of just gray area, legal issues, right? So that's your challenge, right? As someone on these projects, but how do you balance all these things, right? And I think maybe this summation thought here is really understanding which of these voices, is the strongest, right? Which one of these stakeholders is maybe the most important in your project, right? Because you're likely going to have to make some trade-offs. All of these things can't be perfectly in balance. But looking at them and kind of making that decision is something that will be important finding a way to have a successful project, right? When you get to the other side and say, hey, here's why I made all these decisions, to all these different stakeholders, and hopefully have it be a good defensible case. So. Okay, I think that was going to be like my longest pitfall discussion. The next, I think they get progressively shorter as we go on here. So I'm just going to check the chat. No, okay, great. So pitfall 2, making assumptions about data. So this is kind of my model for thinking about a treatment system. And this could be anything. Again, this could be, a filter sock sitting in the ground, or, the most advanced 20-stage treatment system, you've ever seen. So and what this model kind of represents, the blue circle in the middle is just, whatever your barrier to treatment is, right? Whatever sort of control that you put in place to try and deal with your treatment issue. And on the left-hand side is your contaminated water, and on the right-hand side is your clean water. So when I kind of think about this, I say, okay, I have some parameters for my site. Let's say it's copper and zinc, and I have some sort of average range where I've seen these issues show up, right? They're typically twice the NAL or twice my NEL or something else, right? And I know what the max level I've ever seen them at is. And maybe they could even go above that, right? Stormwater is highly variable. And, it's not unusual in my experience to see things swing 5, 10, 20x from one storm to the next, right? Especially if you're a facility that has a lot of exposed materials and other things. So you've got this kind of this historical data set of, known parameters that you're trying to design around. And then you also have parameters that, maybe you don't sample for, but they're things that could impact your treatment system, right? In terms of it being effective. And those are things you might not always know about, right? So this is kind of the data on the left side you're using to kind of make assumptions about your system. In the middle, you have things that are kind of what your system is. It's made up of some sort of combination of fixed and variable inputs. So for example, if you're going to put in a tank, right? Okay, that has some sort of fixed volume in it, but maybe the rate at which you run water through that tank could change, right? Okay, you put in a filter vessel. Okay, that's some size, but maybe the media I put in the filter vessel can change, right? So you have some kind of flexibility with your system as you look at, how many different process steps do I have? What things are kind of fixed? What things can I adjust, right? Once I put it in order to maybe meet changing water quality needs, both as my understanding of my water changes and maybe as permit values change in the future too, right? And then you have your outputs out of the system. So presumably cleaner water, right? Presumably at or below your targets, or maybe much below your targets, right? If you want some sort of safety factor, if my discharge goal is 1 part per million, I probably want to be 0.99 parts per million in perpetuity forever, right? I don't want to over-treat my water, but, I want some sort of safety factor there too. I also don't want to have every single storm event be wondering, am I just going to be under? Am I just going to be over, right? So how do you kind of think about safety factors with what you're looking at on a system? And then you also have some sort of waste, presumably out of most any system, right? If I have a filter, right, I'm building up sediment on that filter and then I'm throwing it away, or I'm cleaning it or washing it, or I'm getting a sludge into a tank and then cleaning that out, right? The whole problem is, there's too much contamination on this front side. That contamination is physical stuff that's getting pulled out of the water. And once it does, you need to do something with that stuff in terms of how it's being disposed of. So keep that in mind, right? When you're looking at a system, that it's not just your copper or your zinc isn't just, going into the universe. It is going somewhere, right? It's going into a sludge, it's going onto a filter, it's going onto a media, etc. So some assumptions that I've seen, made about data when we're looking at, water quality data on these sites, particle size, dissolved metals, and other factors, I'd say kind of are the 3 categories of area that are the most commonly problematic, right? So an example here on particle size. So particle size is just really, hey, of all of the particulates or sediments that are in my water, how big are they, right? Is it, is it gravel, sand, silt, clay, etc., right? The smaller you get, the longer it takes to physically settle out. If I just was to set a cup on a table and let it sit there, large stuff, sink quick, small stuff, not so much. And if you don't know the particle size of your, contaminants in your water, that can lead to some bad design choices. For example, a site we worked with in Rancho Cordova, they originally put in just a oil water separator and a media filter that was going to do about 20, 30 microns or so. And they got good, reduction, 50 to 70% or so of their materials, but they really needed more like 90 to 99% reduction in order to meet their goals, right? And had they done a particle size analysis on the front end, they would have seen that, it was like 70 or 80% of their material was under 10 microns, right? And they were doing 20, 30 micron filtration. So a lot of that material was just kind of sliding right through their filter. So that's one assumption and one area that I would highly recommend anyone kind of working on considering any sort of treatment control. Look at the particle size distribution in your water. It's a test you can send to a lab, costs $100 to $300 depending on what type you do and what lab it is. And it can give you this little chart back and says, hey, here's the curve of all of your sediments. Here's how big everything is, etc. I've got a question. Let's see here. I've found that a treatment system can be excellent, but if there are no up-gradient BMPs pre-treatment train, any system may not be able to get to discharge discharge water to meet with regulatory requirements. I would like your thoughts on that. Yeah, absolutely. I mean, I think the question is kind of how much loading, kind of right sizing the loading to the unit process, right? So if I'm coming into my treatment system, the first stage of my system, can it handle 100 milligrams a liter of TSS, 1,000, 5,000? Probably not, but what are kind of the influent assumptions of each process step in my system, right? Both for solids, for metals, for oils, for kind of my main target contaminants. I'll often kind of put in there, like, when we design a system, like, hey, this is the upper limit, right, of what this system can handle. And you need to deal with, values above that, right, through other sort of things upstream, just sweeping, cleaning, catch basin management, et cetera, right? The other thing I would say kind of on that note is it's only the further downstream you go, the more expensive it is to remove, right? The cheapest thing to do is to keep it out of the water in the first place. The next cheapest thing to do is to sweep it up off the ground before it hits anything else. The third cheapest thing to do is to, have just like bulk, hay bales or, inlet protection or other things that are keeping, really heavy sediments out. The further you get down in those, more complicated process steps and streams, the more expensive, on a cost per pound or cost per gallon treated, it's going to be to remove it, right? So that's kind of a balance I'd keep in mind. And if you want any follow-ups on that, let me know there. But hopefully that answered your question. Dissolved metals, the next item here. So here's a site in Santa Fe Springs we worked with that had an issue primarily with lead. And they put in a adsorptive media solution, kind of a downspout filter solution. They did a good job kind of profiling where it was coming from. They knew a lot of it was from their roof. They were doing a lot of metal lead processing, right? So it would make sense that they had, air stacks on their roof where we're getting these fine particulates out. But really, due to the pH of their water and the nature of the lead coming out of their stacks, all of this lead was really in a dissolved state by the time it hit their outfall. And so, they got some reduction, some kind of adsorptive removal of lead in the media solution they put online, but it was challenged, right? And it was not reducing it sufficiently enough. And I should have put a picture in here. I didn't, but if anyone's interested, I can send this along. Really, what they did, what we found is when we took a sample of this water, brought it into our lab, it looks actually the runoff water looks crystal clear, right? It looks great. It looks like a glass of water when you're first looking at it. But then you adjust the pH to the ideal solubility point for lead, which is around 8.5 or so. And you see all of this material just pop out of the water, right? If you think back to kind of high school chemistry solubility experiments, you reach that solubility point for the lead, and that material just precipitates out. You physically see it, right? The water changes colors. You see the precipitant in there, and then you can grab onto it and drop it out and then filter it, and you get to the end. And, now the end water and the beginning water look the same, but just one of them is without lead. And it was primarily through a pH adjustment process that happened. Now, could I just put some sort of absorptive media on there that would kind of, suck the lead out over time? Yeah, you could, but that on a cost per gallon treated basis, right? Probably not as efficient here as just kind of getting it all precipitated out with that pH step. So, another example here of a site where they did a passive media bed solution. It was a site in Oakland here, and they were doing basically a gravity passive media filter, kind of sand, alumina, things like that, and worked decently well. Actually, I'd say it met their requirements maybe about 80% of the time, but it just loaded up too constantly, right? The loading was too high. So kind of to one of the questions earlier, right? Like managing those upstream BMPs. Now the site was doing really what they thought were really excellent upstream management, but that loading was still just too high, right? And the system they had in was really not designed to handle a loading of that nature. And so that's where you kind of get into, well, we kind of thought we could manage the loading down to here, or maybe they didn't talk about it or think about it. And it was overburdened, right? And so basically that led to the system having to be maintained pretty much after every storm event. And it was a lot of maintenance to do that, a lot of material that was being loaded up, and it just became ultimately unsustainable, right? What they did in that case, we kind of retrofitted a different solution there, and they relocated that system to a different site that had a lot lower loading, right? And we did a new system there at that site. So, okay, some of my data pitfalls. Pitfall 3, time. And I feel like this year, and I don't know, maybe this is everyone this year, but not leaving yourself enough time. There can be a number of things, that take a while on these projects. And sometimes they can go real quick, and sometimes they can go real slow. An example on one here in the LA area that we're doing now. I believe the client, we kicked off this project in April, and we were supposed to go to construction, a month or two later. And the client was a kind of a large, let's say large government, agency with a lot of stakeholders, and they got real detailed into all of the engineering. And the way they had their RFP set up, they said, hey, we want to kind of like do a collaborative, design build approach with you. And, now it got down to the point where, every component was being reviewed and specified and, weighed in by all the different potential parties that may ever service it. And, we still haven't started building the system, as they kind of work through all of these engineering things and think about, well, actually we want it this way, and we want it to talk to this, PLC over here in this plant and this person, and LA needs to be able to view the system, and we want it to be, these electrical components because we have this kind of master service agreement with this electrical parts company, et cetera, right? So, it's the kind of things we can do. But, if you're a large company, maybe, and you have a lot of real specific engineering constraints around, what gets built and installed on your property, something to keep in mind. Another site here, one down in Chula Vista that we're working with right now, the project that we're hoping to get in before the end of the year. The client, originally kind of said, oh, hey, we'll handle the permitting, no problem, da da da. And, you know, we're bumping up against a situation here where they're only a week or two out from needing to have their final permits in hand in order to keep their schedule on track, and they don't have them yet. Will they get them? I hope so, you know, but it's, you know, there can be different, these kind of projects, in my experience, once you put them into, you know, whether it's a building permit, a construction permit, you know, et cetera, they're not often, it's not a normal project for, you know, the city or the county or whoever to look at. And they often don't know what they're looking at. Like, wait, you're putting in a drinking water treatment plant or a wastewater treatment plant? No, that's not a stormwater treatment plant. You know, it's a very new thing. And so you'll get very new and different types of questions and concerns site to site until these become more common, right? Is my, and even, you know, multiple, you know, decade maybe into, you know, these sorts of systems being implemented, it's still a more rare case, right? So that's one example of things that, you know, and in this case, right, it's putting at risk a schedule that's tied to, you know, consent decrees and other, you know, third-party litigation issues. And so, you know, things to be mindful of, right? You know, no one likes having that time pressure on top of all the other pressures that you have. Another project up here in Santa Rosa we're doing right now, you know, just an example where, you know, you start off a project and it's moving forward, everything's fine, you had estimates, and then all of a sudden, you know, in the middle of it, you know, we get dropped a water board order that says, oh, well, actually, this project needs to be done by this date, or you have to stop operating and things like that. And you're like, oh, well, that kind of puts a wrench into the original schedule. And then everyone's all hands on deck, right? Trying to kind of make it happen. But, you know, again, not fun situations, right? Things to try and avoid. So, I mean, how do you avoid that? I guess, you know, being in touch, right, with your regulator, you know, knowing if any of those things could come your way, or even if they do come your way, you know, are they real? Do you have to comply with them, or are they maybe more just asks and, you know, requests versus, you know, mandates, et cetera? You're understanding some of those fine lines. You know, and lastly, another project here, I'd say, especially this year, right? It's been all about COVID, supply chain issues, materials issues, et cetera. Project in Los Alamitos, again, one with a very strict timeline, you know, very detailed involvement from, you know, municipal agencies. And, you know, there are, you know, little $5, $10 electrical parts holding up, you know, many, you know, very large and expensive systems, because the supply chain right now is very, very difficult. And that includes components that go into water treatment, right? So things to keep in mind that are potential risks to a project. So, all right. Number 4, assuming all will go smoothly, right? So kind of just highlight a couple random pitfalls here that I've seen. So one, a site in Long Beach that we did where a client was, you know, had everything planned out, you know, okay, we're going to set our system up right here. It's perfect. It's right by our tank and our outfall. And then, you know, based on exactly where it was, there was an easement issue with the site next door. And it took them about 2 years to resolve. So we shipped all the equipment and it just sat in storage on their site until legally they worked their way through the easement issue. And that was it. That was the only issue that held up the project, right? But it was, I mean, so frustrating, right, to have something like that pop up. Like, you know, could they have moved the equipment somewhere else or something else? Maybe, but they also didn't know how long that easement issue was going to take to resolve, right? At first, I mean, every month it was like, oh, it's going to be resolved next month, right? They thought. But when you're dealing with, you know, other third parties, you know, that you just, you know, neighbors, right? Maybe you're friendly with, maybe you're not, you know, things can come up. Another project here, actually, this is the one shown, was an issue with parking that came up. Basically, they originally were going to put this system, and I'm not a, you know, expert on all of the various parking codes of all of the cities of LA or any other state for that matter. But in this case, they had planned on putting this treatment system on the ground on this site. It involved these couple components here, as well as a couple tanks sitting in the back. And they said, well, that treatment system is going to take up this much square footage, and therefore, because of your site, you have to add X number of parking spaces. And they didn't have any room to add parking spaces because they'd already, all the parking area was already used up. And so it created this weird problem where eventually they said, well, if you put it on a trailer, then you don't have to add parking spaces because then it's mobile. And so that's what we did. That's what they wanted to do. So if you see here, I had actually a similar issue happen up in the Bay Area where it was not a parking issue, but a building permit issue. And they were trying to do something and said, well, again, if you put it on a trailer, then you don't need a building permit. I'm like, oh, okay. Well, that made a lot of things easier for everyone. Another case in San Jose where city came in and said, this stuff looks kind of loud, and I'm not really sure about if everyone in this neighborhood is going to like it. So we would like you to do a noise study on it. Basically, bring all of the pumps into your warehouse and all of the other potentially loud components and, put a decibel meter on them at different distances, and then put that all together in a report for us so we kind of have a sense for how loud the system will be when it runs. Again, on this site, I think there were maybe dozens of things that were louder than this treatment system that I could perceive, but nonetheless, it was, once you're doing a new project, right, you kind of open yourself up to questions, and this is one of the asks that they had. So, all right. And last one was kind of just the idea of Pitfall 5, not appointing a champion. So in my mind, I always think of sites that are really successful as having someone that like a single individual who really has kind of like taken ownership of, the site being successful, right? Collectively, maybe it's their treatment system, their sampling, the paperwork of it, all of it, right? So a couple of examples here, I had one site where, this is actually my one non-California site, but where they had a lot of issues with turnover, right? And certainly, in this, a lot of these industries that we're working with, a lot of heavy industry, materials, scrap metal, aggregates, et cetera, right? It can be a lot of turnover of employees, and that can be a real challenge. In these cases, we're often, maybe, as the vendor, the one that's really most familiar with the site and has the most history and consistency there to offer. But something to be mindful of, right, is, hey, do I cross-train, a couple people, or who are the different people as stakeholders on my team that are really going to kind of know what's going on? And, if they, get hit by the pipe truck, am I okay? Am I not okay? Am I risking compliance, et cetera, right? So we had another client here where it's kind of like a middle ground situation where in Santa Clarita, and we built a system for them that was decently complex, but they really kind of wanted to do it themselves. Once we kind of installed it, right? They kind of said, we're just gonna okay, we got your manual, we got your training, and from here on out, we're just gonna kind of figure it out. We don't need a maintenance program or any service or any, you need to visit us or anything like that, which is totally fine. I'd say, that people kind of know themselves and their business, right? But what this turned into is then, we get kind of the random calls where they're freaking out about, oh, this whole thing doesn't work, and that's wrong, and this is wrong, and I don't know what's going on, and right? Because they, it's new, right? Everything is, a lot of these things are new systems, new controls, and they've muddled their way through it, right? They've actually, they've been successful, right? They've met their requirements, but they've done it in kind of a DIY way, right? And then, on the other end of that spectrum is the people that I don't hear from, but it's for the other reason, right? Because they're fully self-sufficient, right? I call it my Oakland A+ team, on a site there. And, we never have to visit, but there's never any issues, right? And they are, kind of the star kid in their class, right? And they, have just kind of really, in my mind, my perception is they really care about what's going on, right? They've taken ownership of it, they care about it, and they really, kind of champion that success. So, yeah, so I think that is, I'm at my, apparently I had more to talk about than I thought. And here we are 10 minutes still, which is where I was hoping to kind of end for Q&A anyways. And, thanks for those who stuck around, assuming that you did. And I'll hand it back to Rebecca here. So.
Thank you so much, TJ. This is a great workshop. Learned a lot of information. And everyone attending, if you have a question for TJ, feel free to unmute yourself and ask, or you can put it in the chat and he will answer those for you.
We'll just sit here in awkward silence until that happens. Or if it doesn't, then, we'll say goodbye shortly.
And don't forget, we have more workshops this week lined up for Stormwater Awareness Week. You can find all of them on our website. And we have more industrial ones coming on Friday. So be sure to go check out the IGP Basic workshops. There's 3 of them. That will be again on Friday. So
I do have a question.
Go ahead, Aaron.
You mentioned earlier checking the particle size in terms of, and that was a real good point. Is there a particular sample method that you recommend, or how would you approach doing that to find out the particle size of something?
Yeah, so there's a couple different methods. I can't remember the actual method number right now, but in general, like one of the laser methods, it's more precise, and one that will give you both. It'll give you total counts as well as sizes. So it's kind of like a mass. It gives you kind of a better picture of the total mass in there, versus the kind that are just like a sieve test, right? Where they're just doing like physical filters. Those don't really give you they'll give you like bigger blocks, like 50 to 250 or 50 to 20. And it's better if we can get, more precise. And what we're really concerned about is that stuff that's 10 microns and under, right? Or 20 microns and under. So getting real visibility on that, those laser tests help the best. So.
Yeah, you did mention something earlier too. You talked about how episodic water could be. I mean, I've seen water where nothing seems to have changed, and yet they had 2 variable sample results.
Mm-hmm.
How does the treatment system account for the fact that sometimes you can have these virtually unexplainable jumps in something was fine before and all of a sudden now, and you really can't find a cause for that? Do you have any? Mm-hmm. Do you put like a buffer in your system, or try to? How would you approach that?
Yeah. So I'd go back to like this slide up here, right, where I'm kind of thinking about it, and that's a case where I'm discussing with the client to say like, hey, how conservative do you want to be, right? In your system design. I like the idea of kind of right sizing, right? Not undersizing or over designing or under designing, right? In any sort of solution. If I over design something, I'm creating too much waste, and it's too much inefficiency, too much cost, right? If I under design it, they don't meet their compliance often enough. So we're trying to strike some sort of balance there. And I would say that really more depends on the risk profile of that site, right? How, are they just trying to meet NALs, through kind of an iterative benchmark situation, and they don't have other external factors that are, on them? Or is it like, no, they have NELs for 10 things and 5 lawsuits, and they cannot miss another sample ever again, right? I mean, those are 2 very different situations. And I would think about those system designs in terms of how conservatively, how to approach them, and make sure we were having that discussion with the client. So.
That makes sense.
Yeah.
Thank you.
Yeah, very welcome. Thanks for the good questions.
Perfect. Well, it looks like we are getting out of time. So if you missed any part of this workshop, we are going to be putting the recording of it on our website. That should be up in sometime in the next 24 hours. So you can feel free to head over there and check it out. But thank you so much for joining. TJ, thank you for presenting. This has been really great.
You're very welcome. Thanks, everyone.